All right, hello everyone. We're starting a few minutes late, so I'm going to go ahead and get started. Thanks all for coming to the talk today. My name's Ty, and I've been working on various aspects of developer platforms at different companies for about the last 4 years. I started my journey into this more niche space of Android when I was at Evernote in 2012. And after working on there for a couple years, I moved on to Twitter. I worked on the Fabric SDKs and kind of continued working on developer platforms and developer tooling there. And now I've been at Uber for about a year working on their developer platform on the external API team. So for those of you not very familiar with what a developer platform is, it's really the arm of some of these companies that focuses explicitly on the external API, developer tooling and docs, SDKs, partner outreach and integrations, developer relations, and other kind of related tasks that are more focused on getting external developers building on top of that company. Today I want to walk you through many of the experiences and features that I've built at these different companies so that you can have a greater understanding of what goes into this, either for building your own integrations in the future or for integrating against an existing one. But before I dive into these specific features, let me give you kind of a high-level overview of what I mean when I'm talking about explicit mobile developer platforms versus just regular developer platforms and APIs. So a traditional approach to a mobile integration is probably to use an SDK that lives in an app, and that app talks up to some web service, and that makes requests, and that caches the data, and if the user has 6 apps on their device, and they all have the same SDK. That SDK has no awareness of the other versions of it on the device. They all have independent connections. They all independently use bandwidth and suck down the battery and store different spots on disk, even though it could be duplicated data. And in my mind, a more interesting approach is to start to think about providing some of the data and functionality that may already exist on that device in the proprietary first-party application to third parties that may be interested in consuming that. And this sort of approach preserves some of that size and bandwidth that I mentioned could be duplicated in a more traditional multi-SDK to web service sort of integration. It also unlocks a mix of interesting UI functionality where you can have an app call into the main app to do a specific flow that may have been much more complicated to integrate into individual third-party apps, even through pulling in code through SDKs. So I want to start with one of my most recent projects, and this was adding and refining the deep linking support into the rewrite of the Uber Rider app. And for those of you not very familiar with deep links in general, it's just a general term that's used on Android and on iOS to reference a URI, just a standard web URI, that an application can handle. This third-party application initiates a URI, and that, in this case, starts the ride request flow for the Uber app. Now, that URI is just a series of parts that communicate the intention of the deep link. In this example, the scheme indicates that the Uber app can handle it, and the ride request authority indicates the specific action that we want to do inside of the app. And then the query parameter data in this case is the specific parts of the request to indicate, in this case, the pickup. This would be the extra information. By registering the URI information in our manifest, we're telling the Android system that our app can handle that URI. And this can be supplied with a data field this can be supplied to the data field in an intent, or by the user selecting this URL from a browser or an email or some other way where the system automatically linkifies that. Here we're specifying the scheme and the authority in the manifest and defining that in our intent filter. So only that URI that specifically meets our requirements will start this activity. So here you'll see the activity is the ride request activity. So I explicitly have an authority called ride request. If we had other deep links, we may want different entry points that they fire. But since deep links are just a general term used across the platforms, including the web, it's more common to think about them as a standard HTTP link that the application can handle. And it's the same data that's provided, but in a standard HTTP URI. What should happen when the application that you designed to handle this flow isn't available and the user clicked this link? Well, because we're using a standard HTTP URL, also called a universal link often, the browser will handle opening this. We'll want to provide the best possible experience to our user from this point, and more commonly, that requires the user to install the application from the Play Store, and then continue the flow that they had interest in completing by clicking the link. Now, you can safely make some assumptions here. If the user is clicking the link, and it's being opened in the browser, then it was not explicitly opened in the application. So you can make an assumption that it's probably not installed, and then you could use some web APIs to validate that as well. So ideally what you're going to do, if you're at this landing page that you as a provider of this own, you want to fingerprint the device such that you can later use that for attribution information or to allow the user to continue that flow. And then you want to forward them onto the Play Store while giving a refer parameter to the Play Store that indicates maybe either a unique ID that you're holding onto the fingerprint of the information through, or a URL encoded version of the deep link that they originally tried to interact with. Then once the user goes to the Play Store through that link, installs the application, and it launches for the first time, the Play Store is going to fire a broadcast that includes that refer URL information that came in when the user clicked it. So if you had given a unique ID, this would be a great spot for your application that's now installed and receiving this for the first time to communicate with your web service, say, hey, I have this unique ID, what was the user trying to do, such that the app can continue it. Or if you had not used an ID, if you had just done a URL encoded version of that original link, you could then parse that and run that through the same logic that any URI running through your manifest would have run through as well. And that will give the user this flow where they install the app, open the app, and then it continues on to the specific detail page or sign in or whatever they were trying to originally do. Now, with Android Marshmallow and up, the application can be set by default to open a URI. So in previous versions, the user would see the intent picker where they could choose this. And I think this provides a better user experience, and it provides a more enhanced security model. It means that you can guarantee that your application on the device is the only one that's going to handle opening a specific URI. If you had sensitive information in it, this could be of benefit to you. To implement app linking, you'll just need to make two modifications to your app and to your web service. The first is to your manifest, and you'll just want to add this auto-verify tag up here into your intent filter. And this just tells Android to look at all of the intent filters that have auto-verify and then make a request out to the server that it lives on. In this case, it says Uber, but this should be explicitly your URL, like HTTP, your domain. And then secondly, you would need to create an assetslinks.json file with your public key store fingerprint that lives on your server. You can get the public fingerprint by using the key tool, and Android will now make that request automatically from the device, see the JSON file on your server, compare the public fingerprint of the key store that you have defined there with the public fingerprint of the APK on the device, and if everything matches up, then it knows that your application should be the one opening up these URLs by default. Another common mobile developer platform feature is to integrate authentication so that you can call certain endpoints. The Uber API specifically has both privileged and non-privileged scopes for its different APIs, depending on the impact of that endpoint. For example, maybe you want to just get a price estimate. That could be non-privileged, but if you wanted to initiate a ride for a user, that would be privileged and would require additional validation. If we wanted non-privileged scopes, it's pretty simple to integrate just an implicit OAuth grant where you have two parties in the flow. You have the SDK, maybe doing it through WebView, and then you have the Uber login service. The WebView loads it, and it gets an authentication token back from the client ID. But if you wanted to use one of those privileged scopes that I mentioned, like the initiating a ride request, there's a common OAuth term called three-legged auth that we require an integration against. Generally, this means that the client has two things that they own, both the application and a web service. The client initiates the flow. The Uber login, and they provide a client ID. The Uber login service, after completion of the user authorizing the scopes, returns an authorization code that cannot yet be used to get information to the account. The application then has this code. It hands it up to its own web service. That web service has an additional client secret that was registered. Now it combines the client secret and the authorization code that was handed back from the Uber login service to exchange those for a valid authentication token that can then be used to make these privileged requests. As you can see, the process to get at a privileged scope requires a bit more configuration, and it can be a bit off-putting, especially for explicit mobile developers who don't want to necessarily set up a backend. Fortunately, this is an area that has been improved on by a number of companies, and I'm sure probably plenty of you have used this. If you integrate against the installed first-party app on a device, it can be used to validate that second part of the three-legged auth. So in our case, we have the Uber app, which acts as a source of truth. The third-party application with the SDK initiates the flow into the Uber app. The Uber app now acts as that client service with the client secret, and it can complete the flow, the user can authorize, and it can return a valid authentication token, mitigating the security concerns of the very first flow. I guess I don't have a diagram of that, where it's just implicit authorization. Now, there's a few ways I've seen these built out before. I built these in multiple ways, and the most straightforward approach is to have a third-party app call a URI, and the provider app can handle that. And then the provider app calls a URI in response that the third-party app can handle upon completion. That's either success or error. Another way that I've seen it done is by using a custom action and then regular intents with bundle information to initiate a start activity for result from one application to the other, and then the provider application on success or failure calls the finish and set results, such that on activity result is called in the calling package. The Twitter app and SDK was actually built this way to handle some legacy clients that already existed in the wild before it was opened to the general public. A third approach that's kind of similar to the second one is to use the Android account manager to manage the flow. And this is It's the platform ordained one, but it's quite unique to Android, and it requires additional permissions to be requested by the end user. This was especially problematic before the days of dynamic permissions, where you'd have to have get accounts, and if a third-party app wanted to start integrating against your service, they would need to change their permissions, and that would block the auto-update. The Evernote SDK was built out using this one, and I'll dive into what some of the advantages were of that here in a little bit. I think the most straightforward of those is the first one that I mentioned, where you have a URI that's communicated back and forth. It's also platform agnostic. This is the same way that you would do SSO more or less on iOS as well. And there's even an IEEE RFC that's out for this right now called Native Sign-In that defines this flow. So it's being standardized against pretty heavily. It does have some security concerns if you don't really think through the integration too much. That can be mitigated through things like app linking, but then since that's only available on newer versions of Android, you might need to do some custom work, like setting the package explicitly and maybe doing some custom checks against the package manager. I'll dive into those here in a moment. But at a high-level approach, the client app starts a URI, and if that's registered by the provider app in their manifest, then the provider can handle that. And if it's not installed, the browser can handle some sort of flow as a fallback. And then on completion of that flow, the redirect URL that was provided in the setup, generally through some sort of dashboard, you've integrated against Facebook or Twitter or the Uber developer dashboard before, you've seen a redirect URL specified, and this is what that's for. It gets fired, and your third-party application can handle that success or failure in that guy. And that's called once that entire flow is completed and the authorization is done. But as you can imagine, when we're talking about sign-in, security should be quite a concern. So the first thing that I recommend if you're doing an integration with these URIs is to set the package name on both sides. So if the calling app knows who it's talking to, then it should be explicitly setting the package such that that's the only one that can handle receiving this. And additionally, I would recommend that the provider application, in this case the Uber app, before it returns back to the calling application, it explicitly sets the package of what it's expecting to talk to. That way some malicious app couldn't try to get in the middle of that. But additionally, you should validate the signing fingerprint of the application you think you're talking to. Similar to what I was showing with that assetslinks.json file earlier, you should be doing that manually. In the Uber developer dashboard, we request the public fingerprint of the APK, and then we will only talk to an application that is signed on the device with that APK. There's actually a bug in older versions of Android where it was possible to trick an application into thinking that your app was signed by a specific fingerprint when it was not. This is because all the signatures exist as an individual signature on each one of the chains in the trust chain, all the way back up to root. So if you were to take a public fingerprint, perhaps Google's from Google Maps, and then you hacked up a nice little Python script to say, hey, this public certificate is actually the signer of my fraudulent certificate. Now you would have a trust chain that essentially had two items in it. It would have Google's public fingerprint with no chain back up to root, and then it would have your malicious certificate as well. If you didn't package that up and signed an APK with that, in a more naive approach of checking signatures, if you just checked if that public fingerprint existed as one of many in that, which there are many SDKs that used to do that. Since then, there's been a large security push, and I've actually submitted PRs against a lot of these companies, and it's pretty heavily resolved at this point. But if you were doing that, if you were just checking for does one of these certificates match, that malicious scenario that I just described would say yes. This app is, we in fact do think it is Uber. You should go try to sign in with that. So instead, what I recommend is explicitly checking if any of the certificates in that do not match. Then you know that something wonky may be going on, and you should probably not continue the flow. I want to move on to another project that I worked on a number of years ago when I was at Evernote. And this was the integration with Samsung on their S-Note application. They wanted Evernote on the device, the local installed app, to be another cloud provider of the data store that was accessible. And there were a few high-level requirements that we needed to meet from like a PM perspective, and it covered a range of Android components. So I'm going to kind of walk through each of those. The first requirement was that the S-Notes themselves must be browsable in the main Evernote app, along with all the other first-party content. S-Notes also needed to open directly into S-Note from the Evernote app, and upon saving, return back into Evernote, giving the user no idea that they were app switching. And S-Note, the app, needed to be able to create and sync content both synchronously and asynchronously to the Evernote app on the device. So let's go over what that entailed. Diving in a bit more, we needed a consistent contract that we could share for this integration and for other partners that followed after. These were the technical requirements that broke down into engineering requirements. The first was we needed to be able to get the list of notes, either a single note or multiple notes. We also needed to be able to allow the user to get a list of the notes in a UI element. We needed the ability for a third-party application to create and update notes in the app. And we needed to be able to delete notes based on the user's intent. Not lastly, but another thing we needed was the ability for a third-party app to read the Evernote account from the system, discover if the user was logged in, what the syncing preferences were to the backend service, and potentially even kick off a synchronization between the Evernote app and its service. And lastly, we needed to expose certain specific account preferences that didn't exist in kind of a standard Android-y way, like the available space left in a user's account before they needed to be prompted to upgrade from a free account to a premium account. So we could take advantage of many of the standard Android components to build out this project. The first that we really needed to heavily levy was just intents, and I'll do a deep dive into the specifics of the intents that we needed for some of the more interesting use cases around this. We also needed to make heavy use of the content provider, especially when we were dealing with larger amounts of batch data. The S-Note integration, they wanted the ability to have the user syncing to their S-Cloud and have been using that for a while, and then make the switch over to Evernote. And when they did that, they may have an existing set of notes that need to immediately be synced to Evernote. So this batch process was more useful then. We also needed to use the account manager. This is where earlier when I described what the account manager could be used for, we needed it to expose certain authentication information in a standardized way to these partners. We also needed to use the sync adapter for optimizing the network connectivity and optimizing that synchronization between the Evernote local data store and the Evernote web data store. We also needed to use some inter-process communication for specific information that needed to be transferred. So after we go through all of these specifics, I'll kind of cover briefly some of the permissions that could be utilized to add some security to all of this as well. So intents are one of the first components that new Android developers learn, and for good reason. They're crucial to communication between the components on Android, both between applications and inside of applications. And intent can contain a bundle, and that's just a key value store for serialized data, and it allows for one component to provide the data to the next component. But they're not really the most efficient for larger payloads. I'd recommend not sending a full serialized file through, but instead sending the URI that can be accessed through a content provider. And we'll chat about that in a bit. They're also not great for multiple operations in a row. The broadcasting system is running on the main thread, so if you were batch sending intents, you could potentially cause an ANR, which I saw in testing. One of the requirements with this was we were syncing large amounts of data, so we needed to be able to handle these use cases. We also needed to create and expose specific actions. And going further, we needed to create a consistent, rich API around these actions, such that it was easy for a third-party developer to quickly look at that and understand the mental model that we were trying to communicate. So if you wanted to start integration on your app to some of the Android system right away, you could do that pretty quickly by integrating against some of the standard Android actions that are defined in the developer docs. The send action, one of the ones that you probably see very often, it allows you to send data from one application to another. This is often used if you're sharing a photo from the gallery to Instagram. Send multiple is very similar, except it allows you to send multiple pieces of content at once. View is very similar conceptually to send, but it has a different intention. Whereas send is about taking a piece of data and sending it to another application for use. View has the intention that I have a specific piece of data, and I know that a third party is going to be the better one to handle rendering or viewing that application, or that MIME type. An edit is really powerful and a lot like view. You also send out a URI for interaction in another application, but its intention is that third party that you're interacting with on this would be able to edit that MIME type and handle that file and return you a result such that you could continue in your own user experience. There's several things to note here. When we create our intent, we set that action to edit. So this example is, I think, probably one of the more interesting standard Android actions, and also one that has more caveats than some of the others. So we specify a MIME type for the image. We specify the data URI that could be queried from a content provider. And then we call start activity for result, which will load up an activity that a application has registered to handle the specific MIME type that we're defining. Now, on the recipient side of this, we'll implement an intent filter on our activity to handle the edit action for image MIME types. And this will allow our app to be picked by the user when editing images. We then need code to read the incoming intents when they match our parameters, and we can start the editing process at that point. As a receiver, we should be editing the URI given to us by the sender. Next, we'll set the result to OK, and we'll return the original get data intent. Now, on the sender side, we're notified in the onActivity result method. And after verifying it was a successful operation, we can progress forward. Now, I mentioned there's caveats with edit, so I'd like to dive into those a little bit. Some of the caveats are around sending the file from one application to the other. So often what I see is that one application will send the original file over to a third party. That third party may not handle editing that correctly. The user may cancel out of the operation after the third-party application has written to disk. Now, unless they're tracking how to undo that and they reverse their operations, that third party has written to the file you gave them. Comes back to the application, your calling application, as a cancel. The user expects that it did not actually make the change. They backed out of it, they hit the cancel button, whatever. But since it was written to disk and it comes back to your application, and you didn't copy the file, you sent the original over, the user's edits are still there. So instead I recommend making a copy of the file first, sending the copy over to the third-party application to be edited, and then when the on-result comes back, confirm if it was a successful operation. Maybe think about a user experience that would allow the user to say, yes, this is what I wanted, let's go ahead and replace this. And don't always rely on the set result and the on-activity result. If the recipient didn't handle the intent correctly, your data could be in a limbo state for the user. There are activity flags that could cause this not to happen. Kill activities could be breaking in certain applications. They could just not call set result, or they could call it with the wrong data. So another strategy is to instead rely on a content observer on the URI that you have, or potentially to check if the file was modified, to track its state, have an MD5 of it, a hash, and when onResume comes back to your activity, check if that was changed since last time, and see if you need to prompt the user to kind of finish up an edit flow that you knew was started. Now, I talked about some of the standard actions that multiple apps support. However, I want to talk a little more about kind of how you would think about data modeling your own intents. So for the Evernote app, we had the concept of notes and the concept of notebooks. A notebook has many notes. There's some others as well. But we really wanted the ability to have this consistent data model when thinking about any data object that you might be interacting with. We modeled it pretty heavily after just the standard CRUD that you see in RESTful APIs. We had a list intent, which if you were doing notes list, it would take you to a list of notes as a UI interaction. A view that required an ID that would take you to a specific view. New, which would take you to a composer for notes. But then some things that were asynchronous, like delete or update, where it required a specific set of data in the bundle, and it would perform that operation, and then perhaps finish and take the user back to the calling application. And then we provided these for each one of the data models that we expected to be interacted with. Now, here's an example for how the caller could engage with that new node intent that I showed, to just leave the user at the composer for a note with some pre-filled data. We set the action. Here we put a couple extras in the intent with the specific keys that we would have defined and communicated in our developer docs. And we set a URI for an image that we also want to put in the note. And then we can call start activity for result and be notified when that's saved. Although this technique works great for a single piece of data, a single note, let's talk about how you would start to build an integration that handles a larger data set or batch operations. And for that, we need to talk about how to use the content provider in Android. And it's really just a contract to consume and write data for your app. It's just a well-defined interface. It's traditionally backed by SQLite, but because it's just an interface that's implemented, you could back that by a custom integration if you wanted. Something to disk, Berkeley DB, saving to shared preferences. Where intents are great for small snippets, individual pieces of data, single one-off use cases, the content providers works much better for a larger data set, since it is traditionally defined around that SQL and query sort of idea. And you get a cursor back that can be looked to iterate over multiple pieces of data. And the content provider, you need to define a unique authority to be used as well. This, like the unique package on a device for installing an APK, is another unique piece of the application install process. You cannot have two applications on the device that have the same authority in your content provider. So let's start with some examples around content provider. Earlier I mentioned the URI in reference to deep links. Well, I've also shown it a few times in an example of how we perhaps would get an image into the set data that we used earlier for the intents. Well, the URI is pretty heavily used in the content provider to get these cursors out, get specific pieces of data out, and make these queries. Here we have four main attributes. We have the scheme, which is often referred to when doing content providers as content, although it does not have to be. You have the unique authority for the content provider that I briefly described on the previous slide. You have a specific data model that you want to be interacting with. Here we're interacting with the users table, and a specific ID that we might want to query. Now, this last part, the path, is pretty important, especially if you have a larger data set and you're needing to construct complex queries when you're querying, editing, updating, whatever you might be running on for that content provider. Now, we've gone through a bit of the basic fundamentals of the concepts of content provider, so I want to show kind of a simple example of serving and consuming data both. Here we're providing the query method for the content provider. We match on that URI that I just talked through. We set the table to the user's table. If that ID was in the query, then we go ahead and we append that. And then we apply the remaining methods to the query builder and return a cursor for the consumer to use. Now, once we've built up the content provider, we have to be able to access that data. We have to be able to query it. Here we'll hit the query method on the content resolver for the URI that we just showed an example of. This implementation could be used by your own app to query a well-defined set of your own data, or you could export this and it could be used by an external app. Just like we can serve data from SQLite, with these components, we can also serve files from disk. And this is crucial for that edit example that I showed, and I want to dig into that a little bit more. While we have traditional methods like the content provider, like query and insert, to go with the editing example, I'll walk through open file. So we are overriding the open file, which returns a parcel file descriptor. There's a similar method in the content provider called open assets file, which is designed to return subsets of a single file. So it's great if you want to return a specific resource out of your APK, which is just a zip. But open file is actually opening a specific file on disk or perhaps memory. Here we're assuming that the URI path handed to us matches our scheme on disk. And if that wasn't your case, you'd want custom logic to handle that. Perhaps make a network request, perhaps construct it dynamically. The majority of this work is setting the appropriate file mode here, and then handling creation of the file if necessary before we pass it along to the helper to do the actual opening and return that parcel file descriptor. Then the provider serving, if the provider serving files wasn't able to get at it, it wouldn't be useful, right? So we need the content resolver to be able to access the content and then return that. And from that parcel file descriptor, we can extract a regular Java file descriptor and then utilize the standard input and output streams to manipulate that file. Even Bitnet Factory, for rendering your UI, has a method to read an image straight out of a file descriptor. So once you've gotten that out, it's pretty easy to pass that around and use it. The account manager was another one of the pieces that we needed to build out for the S-Node integration. And it's just a system component that groups the accounts provided by the implemented applications. And it can be accessible to other applications for discovery, so they can make queries against it and look up and see what accounts are available. They can also interact with it. They can try to get an auth token out. They can try to access the account if they have the right permission. It also provides helper methods to store account data such as tokens. And it can also assist in things like refreshing OAuth tokens, supports multiple, and can help define access denied scenarios and much more. And it also provides a level of consistency to the end user, where they can view and manage their accounts in one location instead of having to dive into the settings of each individual app. And it provides a better user experience, I think. But how would we track our own app in this and then use that for a third-party integration? Well, first we would need to extend two classes to provide our own accounts here. The first is the abstract account authenticator, which is a service that the account manager uses to communicate with. And then the second is the account authenticator activity, which is the actual activity that you would create logic in to handle sign up and login and all the UI that you want to interact with. Here's a great complex diagram explaining the process from the Android developer docs. This is taken right from developers.android.com. The process begins by trying to get an account token, and on success, the callback is called. And if it will either contain a key intent with information on how to start the authenticator activity, or to finish the process, or it'll contain the token information in the bundle. It's up to the caller to look at that and figure out what they need to do. On error conditions, those get reported back to a specific error callback. So let's cover a few of the important implementation details of the Android diagram that they provide us.
In the abstract account authenticator class, we will need to override the add account method. And that's called when a user explicitly wants to add an account to your application. They go to the account screen, they click your app name, they click the add at the top. So you'd want to return a bundle with information on how to start your authentication activity. So when they do that, you actually want to take the user to your login flow so they get that user experience. And this is then called by the account manager, and it proxies the information into a bundle. We set the activity here to the account authenticator activity that we just described. Now, the getAuth token is another one of the methods that's commonly used and often needs to be used in these sort of app integrations where one app needs to grab a token out from another app. And it's called, and we'll walk through the meat of this implementation a little bit. First, we want to extract a username and password from the account manager. This is just kind of a naive example where you had stored the username and password in an account manager. Ideally, you would not. You would use some sort of primary token for your proprietary app, and then use that token to exchange for third-party OAuth tokens on every request. But this simplifies the example. And then we have our successful code if we were able to walk through that flow. If we were actually able to hit the service, make that exchange of username and password for an OAuth token, we can put that in, and we can return it. But if we get to this other section of the getAuth token method, then we know we couldn't access the user's account logged in information, and so we might need to prompt them to do the login again. So this is another one of those edge cases that's described in that first flow. And then we create an intent to display the authenticator activity. Now, if we're adding a new account, each application will have its own custom authentication flow, but at the end, it needs to explicitly set that information into the account manager so that it can be used by other apps. Once we're done, we populate the intent with all those extras, and the account manager can read those. And then we call set result, and we call finish, and it hands it over. The next component that we had to build against to support the requirements for S-Note was the sync adapter. And it's pretty notorious to get working. It requires a content provider and an account manager to be implemented just to use. And a lot of people just create a stub content provider just to use the sync adapter. At a high level, it's a great, efficient way for the platform to control syncing data on a regular schedule with a web service. And it exposes the sync cycle to the user so they have some idea of data transparency and they can adjust that based on their own data or battery concerns. And since the system is optimizing this as well, it tries to run it when the device may already be waking up from another broadcast to reduce the number of wake locks and preserve battery life. It can also be, information about it can be accessed by third-party applications with the right permissions. So in this case, it worked well for Samsung because they needed to know what our sync schedule was and to be able to kick that off with the main application. And in addition to the interval scheduling, it's also great at working with network tickles from now Firebase cloud messaging, not Google cloud messaging. To implement the sync adapter, we just need a subclass, the abstract threaded sync adapter class. The most important part of this method is the onPerform sync, so it's the one we're going to walk through quickly. It runs on a background thread already, so you don't really need to worry about blocking. And in this example, we use the account manager to get the account that we stored earlier, and then we can request images from our server and then store them to disk using the provided content provider. We also need to create a service for the sync adapter to bind to. So it runs in the same process as the main application to give us access to the resources and the account info. After creating the Java classes that we described, we also need to create some metadata classes as XML that live under the res XML folder. This describes the content provider, the account type. It also allows you to define things like if it can run in a parallel mode, which might be useful if you support multiple accounts and you want to be able to sync multiple at one time. And then lastly, you wire that all up in your manifest by referencing the service, by referencing the metadata file, and everything's happy. We only had to create 3 major components just to get the sync adapter to work. So now we've got that working. How often should we run these syncs? Assuming we wanted to sync on some polling schedule, let's say every hour, which granted is quite ambitious. Your user's probably not creating that much data. You probably don't want to sync every hour. But let's say that they were. Let's say that you did. You might be tempted to implement something like this using the sync adapter. Now, we know that Android is efficient about waking up the device. So if I tell it every hour, it's going to, it's not going to do it every hour on the hour. But most networks, like cellular networks, send network tickles down on the hour. So you might have some person from your ops department come in and say, what's up with our traffic? And it might look something like this, where you have millions of users hitting you every hour on the hour. So to resolve that, you would want to add what's called a jitter to this. You'd want to put some random time interval on this, such that over time you would get a more linear distribution. I'm going to skip the section on IDLs since we're running out of time, but the last component that we built out for the Evernote project was IDLs, which is Android's way of generating specific classes that can allow inter-process communication. If you want more information on this, especially for passing parcelable data back and forth between processes, check out the developer docs. I'm going to briefly touch on permissions before I hand it off. With all of these, you can imagine a lot of security concerns where users' data is transferring back and forth between processes. You can create custom permissions in Android. I would highly recommend them. There's multiple levels of permissions. Dangerous, signature, and signature system are often used to inform the user of serious things that can happen. You're probably going to want to be mostly looking at the dangerous level permissions for this sort of transparency in what you have going back and forth. That's used for things like getting the address book information, privacy concerns, etc. Signature will allow you to have one suite of applications where they're all signed with the same key store. They can talk to each other without having to, and no one else can outside of those key store signed apps. But for creating an open platform, dangerous level permissions are probably what you want to do. And then you can add those to the different components that we described. Here we create a custom permission. We would need to declare that in our provider and use it in our consumer. And we would then need to we need to enforce that programmatically on our provider, where we would check if the permission was granted. Again, this information's in the developer docs. And we could also enforce that in XML. We could define this content provider and put on the read and write permissions. So for all of these product requirements, we are able to solve them using the different Android components that we talked about here today. Now, although these can be really rewarding systems to build, they seem really magical when apps are interacting with each other, they're kind of hard to debug. So I would really recommend using really verbose logging that can be enabled and disabled, creating mock API integrations of these different apps so you can run espresso back and forth between apps. Communicate your data contracts very heavily with your third-party developers. Have very clear developer docs and communication channels. Very frequently seek your users' feedback. Have a beta testing channel. And use strong analytics and crash reporting tools so that when this is in the wild, you know what's going on and if there is an issue. I hope you've had some great takeaways from this today. I'm excited to see more apps in our ecosystem that integrate with each other and create these more magical user experiences. If you'd like to explore more of the recent integration options with Uber app or API, check out our explicit Uber developer site. I don't think I have time for questions, but I will be around after this if you'd like to come and talk more about apps talking to each other. Thank you.